Yo, 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 what it
Yes,
do,
sir.
man? What's going on? We back with another CED talk. This is like the third episode, man. We've been running pretty good so far. You know what I mean? I'm in the building with my dog, Cedric Ortega. What's going on with you, man?
Yes, sir. Yes, sir. We ready. We ready to get it rock and rolling. No, the set talks again. Thank you and the God Killer for creating this space where we get to slow the conversation down. And again, shout out to the God Killer. Of course, y'all missed the episode yesterday because, of course, we were celebrating the God Killer's birthday and the
True
evolution
indeed.
proto God Killer to God Killer.
Oh yeah, man. Make sure y'all go back and check that one, man. It was a good one. If you want to go back in time, today was the day to do it, man. He said, man, I'm gonna put it out there for you. You ain't even got to look for it. Ain't no
Yeah,
secret. You know what I'm saying? So now what you
that
gonna
was
say? Yeah.
yeah, that was fun, man.
He
That was
he said
fun.
I was sued. He said I was sued at one point and I deal with it and keep it moving. You know what I'm saying? I ain't sued on no more, goddamn it. But yeah, make sure y'all check that space show we did the other day, man, where we, tackled proto astronomy versus astronomy, man. That was a pretty good one. We got another one coming up this Saturday, part two. So yeah, man, let's shout some people out in the building, man. Mika, what's going on? I see you, girl. See Ghoul up in the building. Black Sun 403. Got 7K7 in the building. What it do? You know what I'm saying? And like I say, man, there's more to come. You know what I mean? I know more people gonna pull in or whatever. So, you know what I mean? We'll see y'all when y'all get here, man. So yeah, said man, you want to brush them up on last week, man. You know, pretty good one, man. You had some pretty powerful videos on there, man. I think it was very, very easy to understand.
Yeah, appreciate that. Last week, we touched on what evolution actually is, and we slowed the conversation down, and we delve into what all the components are, and we delve into the fact that you cannot use evolution and these type of scientific subjects to quantify and qualify the topic of race, right? We saw
Hmm.
that there is a graduality to it. We saw that you can never evolve outside of your clade. Genetics changed the whole conversation. And that's why we rolled over in tonight's episode. We are seeing a resurgence of race-based science. And the they are using there's an attempt to use genetics and those type of terminologies to quantify racial categories, and it's being done on both sides of the equation. In this
Right.
community, you hear individuals using haplogroups or the fact that there is a component of a particular haplogroup that is dominant in one area and equate that to race, right?
Right.
That's why we need to slow the conversation down. And Ngozi does a tremendous job, but 95, no, 99.9% of the time, he is speaking way over most of our heads. Um,
Most
uh,
definitely.
when he's referring to the L2 and L3, there's an assumption that we understand that that's mitochondrial. When he's talking about these L lineages, there's an assumption that we know that that is the early lineage, and they're directly related to Africa, right? And unfortunately, that is not the reality. A lot of us have no clue what even an SMP is. So that's why I thought it was important in this third episode of Set Talks to do what we do, slow the conversation all the way down, break things down, see what things actually are, see what they aren't, where the misinterpretations lie, and grow from there. When we
Right.
slow the conversation down, we can take all the misconceptions out of the equation and have healthy conversations around these
Y-
subjects.
y- Yeah, yeah, man. Because once I hit the E1B1, I'm lost. As soon as he mentioned it, I'm
Yeah,
like, the E what and the B what? Take the what and left the what? What are
yeah,
you talking about, nigga? You
yeah.
know what
So
I'm saying?
tonight,
I know it's something real, but I'm like, nigga, you gotta first tell me what the E is, nigga, before you talk about the E, then the one, then the B and the one. Like, come on, man. Yo, you
exactly.
forget what you talking to regular schmegular people nowadays, man. You know what I mean? So yeah, man.
And
I
he's so
appreciate you taking the time. I know he know what he's talking about. I know he's doing
yes,
his
yes,
research.
he's
But
absolutely correct, and he knows what he's talking about. But again, EB1, and that's a Neolithic inclusion, and that's a sublayer. And then you have no, you got to
yeah.
check this branch because the L2 branch. Wait a minute, slow down.
Nigga speaking algebra, man.
So
Yeah, that's
we're
I
gonna
appreciate you slowing it down though, the way we can
yeah,
once he said now when he say E1 B1, I want to finally be able to keep up with him and be right there. Okay, boom,
exactly,
that's what that is. You know what I'm saying? And along with
exactly.
the
So
L2s and threes and all that other stuff y'all be talking about. Because
exactly. So
genetics
yeah,
is
this is
is one thing you really got to understand when talking about these things, man. So
exactly. They need to slow it all the way down, take baby steps, and get to where Ngozi is, right? And it's something that I think we as pseudo killers too are responsible for. We have a lot of conversations on these platforms under the assumption that there is a basic understanding of what we're talking about, and we assume that because of the amount of work that we put in. So these concepts they're rooted in our lexicon, but so that assumption is flawed. And as good teachers and communicators, I think we need to every now and then just go back to the foundation, slow things down, put things in its proper perspective and order, and from there we can grow.
mm-hmm.
Yeah, I think it's
True
essential, and
indeed, man.
I appreciate the opportunity to do this. It was a learning curve for me as well. So it is going to be a testament to not only how well I translate the information, but if it correlates and starts to make sense, right? Once we get there and we understand what we're talking about, right? Then yeah, that's exactly the whole idea of set top. Slow everything down, start with terms, what this actually means, what it represents, what it doesn't represent, and go from there. So,
True indeed.
so don't forget to share the show, hit the like button on your way in. That helps support the channel after the show. Go in the chat, leave a comment. That engagement is necessary to help the channel grow. Right now, share the show in your chat or in your Facebook. Get everybody over here. I think with the developments in the near future and over the last couple of weeks in the community, this conversation is important.
True
So whenever
indeed,
you're
man.
ready,
Oh yeah, so I'm about to go ahead and share your screen, man, and do your thing. And like I say, you know how we do,
sure.
man. We're gonna open that panel up shortly after. And anybody got some disagreements or you want to ask some questions, we is all is welcome. You know what I'm saying? Just keep it respectful. You know how we do it. All right, man. Hold on, let me get you in there.
Yes, sir.
All right, all right, man. Go
As
ahead and do
soon
your
as my
thing,
screen is
man.
sharing, let me know we ready to go.
Yes,
All
sir.
right, ladies and gentlemen, welcome to another Set Talks. Sharon, let's go. Tonight, race and genetics when population data becomes social typology. Welcome back to another Set Talks. Tonight, we slow the conversation down again. Few topics generate stronger claims than race and genetics. Some say race is biologically real. Some say race is purely social. Others say genetics settles the matter entirely. Before taking positions, we need precision. Human genetic variation is real. Population structure is real. Ancestry patterns are measurable. But measurable variation does not automatically equal biological race. What exactly is being measured? What level of biology are we talking about? What does the data show? And where does interpretation begin? In this episode, we will examine what genetic clustering is, what haplogroups and SNPs actually represent, what heritability does and does not mean, and how typological thinking turns statistical patterns into fixed categories. No ideology, no dismissal of biology, no exaggeration of it, just method. So let's begin. Close Clustering, what it is and what it's not. Genetic clustering is a statistical method used in grouping population genetics into to group individuals based on similarities in their DNA. More precisely, genetic clustering is the process of analyzing genetic variations such as SNPs across individuals and grouping them into clusters based on patterns of shared genetic similarities. Right, so you have that long DNA chain, right? So we know the whole human genome, it's been mapped. So now knowing exactly where all those letters are, we can start to, by measuring groups of people, start to see where these variations are, where these mutations took place. It does not create categories. It detects patterns that already exist in the data. Statistical analysis. A haplogroup isn't a genetic thing. It's not a thing that does something. It is a name that is given to a group of SNPs. These are single nucleotide polymorphism. So genetic clustering comes from SNP variation, single nucleotide polymorphisms. Allele frequency comparison. So what happens when you get an SNP change in a single nucleotide? You have an allele frequency change. There's a change in the allele frequency. They compare the amount of allele changes, so they are, again, a statistical comparison. Statistical modeling, for example, structure type algorithms. Principal component analysis. These methods group individuals based on shared genetic similarities. Each one of these groupings gives you a different something. Take a listen, and this is important.
Let's talk about 3 clustering algorithms in 90 seconds. First, k-means clustering. This is always the first model that I try if I'm clustering or segmenting my data. And the reason is because the outputs are interpretable. So I can take a look at each of the cluster centers and name each cluster. But the con is that the clusters always end up sort of spherical. However, this is the simplest clustering model, so it's a great starting point even if those clusters end up being spiral-like. But if your data isn't shaped that way, then I like to try hierarchical clustering. So the main pro here is that you're able to create this really cool visualization called a dendrogram, where you can see the hierarchical structure of your data. But the con is that it's computationally intensive. So the distance between each pair of points is calculated again and again, and that's a lot of logic for your computer. But this is an excellent way to visually map your data. Another great technique is called DB-scan. So this is based on the density of your data points. What it does is it finds multiple dense regions in your data, and then everything else is called an outlier. So this is great if your data is oddly shaped or there are a lot of outliers in your data. The main con is that there's a lot of parameter tuning involved. So you have to try out multiple density and region size values to see which combo works best for your data set. And that can be a process, but this is very powerful. So in summary, if you want to cluster your data, start with k-means clustering. If you want to create this cool tree visual, go with hierarchical clustering. And if you also want to detect outliers, then go with DB-scan.
So what you just heard is that statistical models are applied to the DNA, right? So the genome is mapped. This analysis is run. The particular region is taken, and these models of analyzing data is applied to the data, to these SNPs, and these allele frequencies. These models are used to compare them. So keep that in mind, because we're going to be examining and looking at several of these models as we continue. Clusters are statistical grouping dependent on sampling, dependent on the sampling, right? So it's sensitive to how populations are defined. So it's nothing fixed. Based on what you are what you're wanting to analyze, you are going to see that these are gradients, not categorical. Remember that, it's important. So if you are sampling Africa, Europe, and East Asia, you will get clusters. Now, if you sample Africa in itself, you will get subclusters, right? West Africa versus East Africa, North Africa. These give you subclusters. If you sample Italy, Spain, and France, you will get finer clustering. What is that telling me off the rip? If I know anything about human migration in general, right? Once you leave, you are going to get bottlenecking, you are going to get a smaller genetic pool, and thus a faster genetic drift is going to occur, and you're going to get finer clustering in Italy, Spain, and France, right? Clustering always appear when genetic similarities correlate with geography. Why? Because what are we doing when we are looking at haplogroups? We are looking at early human migration patterns, early human, deep ancestry. That does not mean nature created discrete races. It means human population exhibit geographical structure. This is population genetics, my friends, not racial taxonomy. Far too often, haplogroups are being used in racial conversation when it obviously has no implication on racial taxonomy. Haplogroups and SNPs. SNPs is single letter variation across the genome. We talked about that in my previous episode, but we can take a closer look at it here. Clustering used thousands of SNPs to detect similarity patterns. Now look at the SNP example on the right of the screen. In the particular point, you see that underneath you have a G always accompanied by a C. You get a variation, you get a mutation, you get a single nucleotide polymorphosis, it changes, and you get now A, and once you get an A, automatically it's going to be supplemented with a T. Here is one point in the measurement, in the random place that they choose to measure in the primarily in the non-coding codon region. This is what they measure. Now you are going to take thousands of these and compare them. And that comparison is what gives you haplogroups. When you see a variation that becomes distinct from the other. This is just again statistical measurement, the variation that takes place in your genome. Single nucleotide polymorphisms. Clustering them is using hundreds or thousands of them to determine variations. You look at the patterns, changes in these thousands of SNPs, and now you're going to apply the statistical modeling to that data. It's computational, computer-driven. So no SNP is exclusive to a race. So these changes happen randomly in particular regions and has nothing to do with race and will not tell you anything about race. Which race are you looking here at? Doesn't define it. So frequencies differ and the presence overlaps. Remember how these any aspects, any traits in any particular population is going to overlap with any other particular population. This distinction must be clear. So again, slow it down there. SNP only represents a change in allele frequency. You are going to get a change in that particular nucleotide, which is a amino acid. It's going to switch out, and we look at where these changes are. And if you have 10,000 people, you're going to look at where this change here in this group. So now you're going to use statistical modeling to create these haplogroups and patterns that we see. So the DNA lines we look at, haplogroups trace either the mitochondrial DNA, which you inherit from your mother only, and in males you have from your mother and your father. Y DNA chromosome inherit from your father. So that is inherited from father to son to son to son, right? So what we are measuring is ancestry. And if you understand that one particular group, haplogroup, one particular ancestry becomes dominant in a population, you must put your mind to understand that we are looking at small splinter groups, because in early human population, they were relatively small groups, right? You got bottlenecking, you got genetic drift, groups die off. So it is understandable that you are going to get a particular haplogroup dominant in a region, because its origins were from very small groups of people. Second, mutation markers. Haplogroups is defined by specific mutations that appear at certain locations on either the mitochondrial DNA or your male Y DNA, the Y chromosome. Three, tree structure. Haplogroups form a hierarchical tree. Why? Because there's a particular chronology there. So when you are looking at the data, haplogroups are going to form naturally a hierarchical model. So this is the way haplogroups are going to be represented in primarily in these hierarchical dendrograms. You with me? Macro haplogroups are the big branches. So in the female lineage, in the mitochondrial lines, you have L, M, N are the major lines. And I'm going to explain why there seems to be some confusion with the lettering. It's really simple. And haplogroups now with the smaller branches, again, in terms of the mitochondrial line, you get letters like H, then you get subclades. So these are now twigs of these branches. You get H1, H3. So you will get there's where you get these terms like H3 and then H3B1, etc., etc. Each branch represents a shared mutation inherited across common ancestors tens of thousands of years ago. It's nothing recent. And there's a particular reason certain groups of people will never be part of forming the baseline for how we develop haplogroups. Us here in the West, due to our migration and our recent history, we do not represent an ancestral lineage in a particular place. So you can understand the specifics required in collecting this specific data. Once it was understood that we can produce hierarchical statistical data, which maps cleanly onto human migration in and out of Africa.
Hey, said you know you're not sharing the screen, right?
I'm not sharing the screen?
No, it was earlier, but hold on. I'm trying to see because it's showing that you're sharing it, but it's not up there.
Uh-oh.
I'm trying to see. That's your music, right?
Yeah.
Okay. So yeah, for some reason the screen is just not sharing, but I see you sharing it down here, but it's not on the what's the name?
It's not up on the screen?
Oh, let me see. Yeah, try to reconnect.
Share screen again. I'm sorry about that, ladies and gentlemen. Share entire screen.
There you go.
Am I sharing?
Yep.
Yes, sir.
Yep.
Okay. I'm sorry about that. Do I need to go back a couple slides?
It's up to you. Yeah. They said go ahead. Yeah, they said go back a couple of slides.
Yeah, I think it's important to go back at least here. So again, SNPs, I don't mind doing this over. Single letter variation across the genome, right? So here you have these base pairs. Base pairs always line up with a G and C and A and T, right? So you have, this is a genome, the top bar is one individual, the second one is another individual, right? And now they do the comparison and they say in this particular region where we're measuring, we see here a SNP, a single nucleotide polymorphosis. There's a change in the allele frequency. So now this is an allele. You have now original, and you have an allele, because now this is a change from here to here. So now what they do in statistical analysis, we take thousands of these SNPs, right? And we look at them, from thousands of individuals. And you're now going to start to detect similarities, right? And these similarities produce patterns. And that's what we're looking at. But no SNP is exclusive to a race. This is a genome. This is a particular random spot. These changes are usually in the non-codon region of the genome. So they do not code for anything. The non-codon region. So they do not affect your skin color. They do not affect your hair type. They do not affect none of these things. What we are looking for is in either the mitochondria or in the Y DNA, which determines your sex. So haplogroups are just statistical groupings which provide us with certain information. And what we discovered is that we can now map old ancient ancestry via the data provided from the collection of genomes, and applying these statistical models, we have now this thing called haplogroups. So frequency differ and presence overlap. Like I said in my previous episode, any particular trait that you are going to look for in any particular group is going to overlap to some degree with any other group. The frequency and the amount of overlap may differ. The distinction must be clear. So I hope that this is clear. An SNP, which a clustering of SNPs, which determine a statistical variation, says nothing about one's race. It says nothing about your skin color. It says nothing about your hair type. None of that. These things are primarily defined by autosomal DNA and not mitochondrial or your Y DNA. These are the aspects that determine your sex, your gender, or your sex, whether male or female. Let me be politically correct. SNPs and haplogroups. So the DNA lines we look at. So haplogroups trace either the mitochondrial DNA inherited from your mother only. So we never look at the X chromosome inherited from your father, right? Only look at the line inherited from mother to daughter to son. Y DNA, which is exclusive to male, is inherited from father to son to grandson to grandson. So that is a direct lineage going all the way back that you can track, because that is passed from father to son, that Y chromosome. So now the fact that that Y chromosome is consistently passed from father to son, we can now look at a group of males and do the SNP analysis, right? Look at where these single nucleotide polymorphosis are within the predefined areas, and now we can do clustering again and determine different and look at different information that provides. In terms of haplogroups, it provides us with ancestry. We can look back at lineages, where they diverge, and how humans migrate, right? So it is evidence, it is real-time genetic evidence supporting the out of Africa migration theory. So second, mutation markers. So haplogroups is defined by specific mutations that appear at certain locations in the mitochondria or the Y haplogroup. I hope y'all are with me, right? So it is statistical data we're looking at. Statistical data. So this haplogroup represents that phenotype, and will know that these group of people look like this because of this haplogroup. That's all nonsense. Misuse and abuse of haplogroups. So haplogroups now, based on looking at the information, we realize it forms a hierarchical structure. That means there's a chronology to how this works, right? We can put it in a hierarchical structure because we can clearly see this tree formation, the branching that takes place. So you have the macro haplogroups, the big branches, and again, in terms of mitochondrial DNA, you have the L, the M, and the N line. I'm going to explain why this particular phrasing and lettering is done this way. But the L, M, and N line corresponds with the oldest lineages. I'm going to bring that insight for you briefly. So now you have smaller branches that produce. These are sub branches that come out of these major branches, right? So for example, you have L, you want to get to L3, L3 gives rise to M, M gives rise to smaller branches, and these are the haplogroups, like for example, mitochondrial DNA H. Then you have subclades. So these are now twigs, right? Off that line of H, you can now see H1, H2, H3, because again, specific mutations that occur in specific areas on that whole broad thousands of single nucleotide polymorphisms that are being examined. Again, statistical and computational. You will not be able to do this by sitting down and looking at a genome. This is done by computer. Each branch represents a shared mutation inherited from a common ancestor tens of thousands of years ago. Again, illustrating the fact that this is deep ancestry, not modern definitions. Deep ancestry we're looking at, right? So we're looking at deep ancestry, not modern times, and small groups of individuals, right? For particular haplogroups to become dominant in any particular region, you are predominantly departing from small groups that splinter off. You have to take into account bottleneck effect, etc. But I'm going ahead of myself. So what haplogroups tell us? Your haplogroup shows your deep maternal or paternal ancestors was. It shows migration patterns and historical connections. It does not tell us modern traits like eye color, height, or personality. It doesn't. So why SNPs and haplogroups do not equate to race? So a haplogroup, again, is a linear marker, usually mitochondrial, for maternal, and Y chromosome for your paternal. They track ancestry lineages. They do not define the whole genome. An individual, let's slow it down, can carry an African mitochondrial haplogroup. An individual, a modern individual, can carry an African mitochondrial haplogroup, so from his mother's lineage. He can have European autosomal admixture. So that means his parents have European DNA. Asian paternal lineage components. So his father's line can have Asian paternal components. So his Y DNA can have Asian markers. And the individual can represent what you think, quote unquote, is an African American. I'm gonna leave that one right there for a second. And what you're looking at, again, in this graph on here is an hierarchical dendrogram. So on the left, you see Y chromosome distribution. So now you have two sets of individuals. You have a male and a mother and a father, the blue, produces a son his mitochondrial, his Y chromosome is blue, that comes directly from his father. On the other side, you have a daughter that gets the Y, that gets an X from her father, which comes either from the father's mother or from the father's mother. It comes from the father's mother, but it can come from either the father's grandmother on one side or the other side, because mind you, the mother has two X chromosomes, only one is passed on. One she gets from the father, in this case here, and one she gets from the mother. So this is a 50-50 which one she gets here. However, their offspring only carries the Y chromosome from the father in the blue. So when we're looking at Y chromosome and haplogroups, there's one male that has been completely left out of this equation because that ancestry did not pass on to his daughter. However, aspects and traits of this individual, the gray individual, is going to be evident in the son, and we'll see that in just a second. Let's go all the way over to the mitochondrial DNA, right? So you see these two, the gray, they produce a son. The son has X from his mother, mitochondrial DNA from his mother, and he has a Y chromosome from his father. This couple has a daughter. The daughter has two X chromosomes. She has no Y chromosome. So no ancestry of her father is evident in her lineage. These two individuals produce offspring. Both offspring are going to carry, so boy and girl are going to carry the mitochondria that comes from the mother. The father, in this case, will only produce one lineage, but in this case, we're looking at mitochondria. In the middle, we're looking at autosomal. So now here we're looking at Y chromosome, which gives you only one lineage. Now autosomal is going to give you all the information. So each one of these parents represent, quote unquote, a distinct area: Asian, African, North African, or West Central African. This is Native American, and this one is a Levantine. The offspring is going to contain autosomally inheritance from all ancestry. So when we're talking about migration patterns, we focus on Y chromosome and mitochondrial chromosome to track migration patterns and early ancestry. Autosomal DNA will give you more of your family tree and who, etc., more of your overall genetic makeup. Do not confuse these aspects. For haplogroups trace one lineage path. It is nothing to do with biological race. Is everybody with me? You see how they misuse this information? Put a one in the chat if you're with me. Let's continue. Mitochondrial haplogroups versus Y chromosome haplogroups. Is one better than the next? Are they interchangeable? Are they? Well, let's look. So mitochondrial DNA, your maternal lineage, is often better for very early migration. Why? Smaller genome, right? So there's less to analyze. So it's 16,000 plus base pairs. It mutates at a relatively steady rate. Easier to sequence from ancient remains, found in many copied per cell. better preserved in ancient DNA because mitochondria is the fuel of each cell. So you're going to find it's easier to preserve mitochondria information versus your Y haplogroup, right? So because of this, mitochondria was historically the foundation of early human migration models, including work related to mitochondrial Eve. So the research started in the Americas, the peopling of the Americas. So this is where the research started, and there's where A came into place. As they continued to do the research, B, C, D, so we ended up with L being in Africa, whereas L should be A as the earliest starting point. They changed that around when they went and did the Y haplogroup, but this is why there's a different lettering in the female or the mitochondrial line, your maternal line, versus your paternal line. This is where that lettering comes in. It's going to be made clearer. But again, the modeling began in America, the peopling of the Americas, and they went back to the early Eurasian dispersals, right? So first the peopling of the America, and based on doing the studies, they started to track back, and by the time they were done, you ended up with L, O, and to 1, 2, 3, and 5, and 6 being Africa. So when you hear and goes, you say L2, L3, he is talking about African lineages. Okay, and once you hear L, M, and O, once you hear these numbers in these letters in reference to haplogroups, it is most likely talking about mitochondria, which is your maternal line. So the Y chromosome, the paternal lineage, what is the information that we were able to derive from researching, from applying statistical analysis? So the Y chromosome has a much larger non-recombining region. Of course, when you get the recombination of genetic material to produce the zygote, right? The area of non-recombining when you have the Y chromosome formation is much larger, right? So you have a much larger non-recombining region. It contains many informative SNP markers. So now we can have a lot of information that we can derive here. It can flood us with information that we can apply our statistical analysis to and produce a whole variety of information, right? Can show finer branching patterns in some regions, right? It is especially useful for tracking male-specific expansion, understanding founder effects, studying population bottlenecks. For example, some Y haplogroups show evidence of rapid male line expansion during the Neolithic and Bronze Age. So while the small group dispersed, and that small group was successful, right? You have 3 brothers carrying a particular line. These brothers branch off. They start to reproduce, and so on and so on. And that population mixes. Again, you saw how that Y chromosome carries on. So that particular lineage is going to be dominant, although there are other males that produce females. When we see that this small group expanded out, and based on how it is passed from father to son, the females will not be carrying the Y lineage from their fathers, whereby making a particular Y haplogroup dominant in the population. So clustering depends on data sets, different population, number of SNPs, or geographical sampling can produce different clusters. So when we hear haplogroups and these type of terms, we need to, there is no racial conversation. We are looking at population genetics, particular features, particular attributes, We're going to see that in just a bit. So clusters do not equal race. They reflect ancestry and population structure, not fixed natural categories. It can't be because we are applying statistical models to extract data. So overlap is common. Most human populations share the majority of their genetic variations. Gradients, not boundaries, are the norm. Genetic clustering is a tool for visualizing and analyzing ancestry patterns. Again, it relates directly to the out of Africa model and theory, right? This genetic work is what solidified the out of Africa model. Again, we took the genetic, we took the genome, we started to map people of deep ancestry that go back, that can tell you they've never left this region. Those are hard to find. You find those pockets of people, and you measure the genome. You have all this data, and now you run it through statistical analysis, and it provides us with patterns. What came out? Hey, we can do this thing called haplogroups because we can see a chronological change here in these regions. There's a chronology to it, which gives us a hierarchical variation. And when we do the analysis, we can see how these variations are moving throughout different populations. Wow! It is data-driven, flexible, and probabilistic, and only becomes a problem when people refine clustering in clusters into social categories or types. And put a knock it off there. So again, this graph is forever needs to be solidified in your head. Whatever characteristics you want to apply to a race, it is going to overlap significantly with any other particular population. I'm going to say it again. Any particular attribute, any particular trait, any particular thingy that you want to attribute to race is going to overlap with any other population, almost like this graph you see. There is going to be overlap. This is teaching us that this concept of race falls to the wayside in terms of biology and in terms of the information generated by haplogroup information. Haplogroup lettering, hierarchical dendrogram. Clearly here you can see that because it starts chronologically A to R, we are looking at the Y haplogroups, the major groups, A and B being very old ancestral lineages. The conversation really starts at C. From C, you get the production of haplogroups D and E, E being the major African lineage. C also formed haplogroup F. Out of haplogroup F, out of Africa, you get the major European haplogroup dispersal. And of course, you get the long lineage of those haplogroups that went into isolated regions of Oceania, which would be haplogroups O and M, right? If I got some of it wrong, of course, we got Ngozi and Gullah, who is going to give you a much more detailed explanation. This is to slow the conversation down so we can see what information you can derive and what information you can't derive from haplogroup. Let's continue. So, I talked about it being hierarchical, and you can see, so haplogroup A is very old lineage, rooted in our common ancestors 200 to 300,000 years ago. You have the haplogroups A and B. very archaic haplogroups. We're going to see the region in which they are still present. Then you have haplogroup CT forming around 70 to 100,000 years ago. That gave rise to the haplogroups D and E, as you can see, 65 to 75,000 years ago. C also gave rise to CF, which was 55 to 65,000 years ago, and these are the out of Africa models. The CF produced where you got the lines C and F. F produced the lineages G, K, I, J, K, and G also produced these. So you see the distribution of G, H, I, J, and K. They come out of F. These are the European major lineages. J is the Levant. Again, you go over further, you see chronological development and dispersal of these haplogroups. Again, genome information, looking at the data, this is what rolls out. We have the molecular clock, and these are all statistical models that develop up until you have 25 to 30,000 years ago, the development of the R1A and the R1B. Don't be surprised if some of us have that R1B as our as our Y line. You'll see why it just fits. So now we're going to look at the mitochondrial lineage. Now, remember, I was telling you the study started in the United States with Native American. So that's why they began the lettering. They're based on the data that rolled out, right? The lettering produced A, B, C, D, X, right? X came later, of course. And so that's why there's a little difference in how the lettering is used, and it's not strictly chronological. Underneath, you can see the hierarchical dendrogram again, starting at L0 and ending at U, and it gives you a chronological emergence of these haplogroups, right? This is what the data produce. Map it on to the genetic, map it on to where the data was collected, you start to see the emergence of patterns. So you have the African linear lines, which is L0 up and including L6. You can see that L3 then went on to produce the lines M and N, and these went on to produce other subgroups. So you see the major groups represented here, you see the subgroups represented here, and you see the major groups, the haplogroups, and the subgroups all represented here in, again, a hierarchical dendrogram. Statistical information representing the mitochondrial line out of Africa migration. So now, this was the initial information collected by key mean clustering, right? Just grouping the data in as much general form as you can get it, right? You can see, if you look into Africa, you can see right there by pygmies in Sudan, you get the early lineages. That maps up with the information that we are finding, right? By the Ethiopia, in that area, you see the oldest lineage A. You see it also over there in Ethiopia and in Sudan. So you see in Sudan has a larger population exhibiting this particular haplogroup. Then you see B also in the same region. And then you go over, you see E3B. Back. This EB3, if you go back, you see that it emerged. EB3, this lineage, it comes out of the C line, and we see in the chronology 50,000 years ago, around 55,000 years ago, you get the C line formation, right? So you can see the chronology here and how it works. Look at the J line. Arabian Peninsula, and you see some of it up here in the Horn of Africa. You see the dispersal. West Central Africa, E times EXEB3, different from EB3 in North Africa and in the Horn. See, it's a different markers. South Africa. What you see here is the Bantu expansion. Okay, EXE3B. But what I'm showing you is the different information that you can get of haplogroups and how you cluster them. By k-means, you get different type of data than you would get with other type of, for example, DB scan. We're going to look at these different models. You can see in the Americas, you have primarily the Q, and when we look at the lettering, you automatically understand that this is the Y haplogroup. Starts with A in Africa, and it chronologically moves out. You can see here, the D is before the J marker. That means this is the early line that moved out. Isolated regions produce the O markers, etc. And you go down into the Australias, you get the K marker, and you see here very early C lineage that moved out of here. Another dendrogram, much more divided, which we talked about, right? Once you go up into Europe, you're going to get much finer clustering. Why is that? Bottlenecking. Small groups go out. The pool is smaller, so you are going to get genetic dispersal at a higher rate. Going to look at, so what we're seeing here again is a k-mean clustering. And you can see the recent admixture, this recent addition, especially of R1b, which was in the Neolithic expansion, that this particular haplogroup pretty much took over Europe. Doesn't mean one individual. It means one Y haplogroup. Remember, the other male individuals that produce the daughter, that produce the sons, that produce this Y haplogroup, have a father. It is simply how ancestry is measured that you get this type of data being produced. All right. So now, look here, the Bayesian tree topography of African mitochondrial haplogroup based on 39 samples representing major haplogroups. So now we have the major haplogroups, and what are they comparing? Region and language. And we are looking at the haplogroups that correspond. So you're looking, for example, if we look at the LO region here, the LO region, you would see that that is in Southern Africa. That is this region. And what is the primary languages spoken? You have the Khoisan, which represents one of the oldest line, the LO, LOD, LOK. These D and K are what we call those twigs, those little twigs. You see the F and the B. These are all the twigs off of the LO lineage. Then you see the L1. Boom, this is the point L1 comes into play. And you see the languages that are spoken. You see it is Khoisan being spoken, Niger Congo, and some admixture from what's that language? From Afro-Asiatic, right? And what is this region? When you start to look at the region, if you look at the combination of the languages, you're going to be somewhere in this region, right? But it's not a one-on-one overlap. You see the dispersal. If you go up here, and if you look at the languages in the area, you can see these are much later lineages, and these are North African lineages, and the language is primarily Afro-Asiatic. You see again how the data correlates, statistical data, and you are looking at different models. What you're looking at is a hierarchical dendrogram, again, indicating region where particular haplogroups are dominant, and they are looking at the languages being spoken, and you can see how admixture and overlap is taking place. There is no singular particular region, only in this region here, which would be the isolated peninsula. Continue. Another distribution. What kind of distribution would this be? Would this be, let's do it. Put a 1 in the chat if you think it is hierarchical. Put a 2 in the chat if you think it is k-mean distribution. Put a 3 in the chat if you think this is a DB scan analysis. I'm gonna wait a second. Let me see in the chat. What do you think it is? Is it a dendrogram, hierarchical dendrogram? Is it a DB scan? Or is it a k-mean distribution? The shapes should tell you already that you're looking at a DB scan. And based on the legenda, you can see what they're looking at. Again, languages spoken: Niger-Congo, Nilo-Saharan, Afro-Asiatic, Kodofian, and now here you are looking at the genetic clustering, the haplogroups, right? So now let's take, for example, Southern Cameroon, orange. It's represented by the orange. Now, if you look at Southern Cameroon, where the orange is, you can see the distribution, right? And the overlap and the intermingling that's taking place. Now, the fact that it is a circle in the graph, that means it's primarily Niger-Congo languages, Bantu languages that are being spoken, right? Now, you look at the purple, which is Chad, Balala and Chad Kaba. You see the overlap between the two. And again, if you look at the language based on the circle, Niger-Congo. If you look all the way down here in Southern Cameroon, right, you see again orange and the language 0 that's being spoken. So let's go up here in the Fulani region. Fulani region, you have different groups and different languages being spoken. But you can see the Afro-Asiatic language being spoken by Sudanese clustering, and you can also see in this same area you got northern Cameroon, and you have Congo Republic, where you have Niger-Congo being spoken, and you have Afro-Asiatics being spoken in this region. So 2 graphs, different models, different data sets. Here, it is showing you how the DB scan works. So remember, the lady explained that it is how you prioritize your data points, how you have to sample your area to see if you get particular clustering. And so you can see the 2 different data sets produced by the selectivity of the data that you're analyzing. Same regions, same data, but different parameters. Then you get different clustering in the DB scan model. So again, when we are talking about haplogroups, we are talking about statistical data. Mitochondrial DNA dispersal out of Africa. You can see L1, L2, and L3. These lineages move out from M and the dispersal. So again, remember the study was started in the Americas with the indigenous people. So that's why the lettering started here, A, B. You go down to South America, you get BC, you go to Oceania, etc. So that's how this lettering in the mitochondrial haplogroups came to be the way they are. So when Ngozi and Gullah are talking about L1, L2, and L3, you know they are talking about mitochondrial DNA from African early lineages that dispersed out of Africa. So A and B, Africa. C, that's early Africa. And you have the development of D and E. These move out to East Asia, Andaman, Tibet, and E remain the dominant lineage in Africa. Remember that? That's a dominant lineage in Africa. You also got from C, produced CF, which we talked about. C and F are the Asian, East Asian, Oceania, indigenous Australians. You have G, the Caucasus, Europe. H, South Asia. I is Europe. J, the Middle East and North Africa. We all gonna remember that one because that J is the topic of hot debates around this community. Then you have K, you have N, sorry, that's North Eurasians. You have O, that's East Asia. Q, Siberia and the indigenous Americas. This is the male, the Y chromosome, of course. And R, you have Europeans and Central and South Asia. So this R is the youngest haplogroup developed, and that was primarily in Europe, Central and South Asia. Early African lineages, right? So the A and B are the early African lineages. CT also developed in Africa. Then you had D and E. These are mostly African and some limited to Asia. And of course, you have the CF. The CF forms an ancestor from nearly all Eurasian and indigenous American white lineage. So once you've got this framework in your head, you can clearly understand the conversation much better, and you can clearly see the migratory path that was taken from early humans out of Africa. No race. So here you can see now R1B1, that's that European lineage in the heart of Africa. That means that these Chadaic people are Europeans, but it is from that R1B that we know that that's a late development in Europe, back migration. You can see that E lineage being predominant, that Niger-Congo lineage, E3A, and you can see that the Dogon, they have E1A, they remain isolated up on that plateau up there. These remain an isolated population, which is something we understand, right? It's not something that's alien to us. We understand that. Now, this is the area we are mostly talking about. You see that J1 area here? See that J2 that dispersed out? And you see that J1 that stretched all across here? That's North African component. See? And you have in the Berbers, E3B2, and then you have the North African component, again, these different regions, and you have the E3B1. That is a distinct from our E3A, and we share that now in that Niger-Congo basin. Now I'm looking, and you can watch the early dispersal. You see how, boom, lots of migrations out. These are going straight to Oceania. That's that early sea line. Here you get the development of the K, I think. The KM, yes. Now we go and look, you see this line, you come back into Europe. Split here. Eurasia, come into the Americas, down the lineage stayed in Siberia, and there you go. This is what we are tracking and looking at with haplogroups. Early human migration. Early. One more time. That's represented here. See three early lineages. B2. No more B2, huh? Seems to died out. Was it still there? Didn't migrate anywhere. See? Stayed within the house of the pygmy people. You see these genetic isolated groups. Look here in Australia. See four genetically isolated. See? R1b moves all the way through Europe. And you can look at the layers. You see the layers of genetic flows in different layers. If you watch, you can see all the components on top of new ones. This is just mapping human migration. That's what haplogroups mean. Now let's take a closer look at that at France and what does that graph mean? So we understand the chronology. So if you see R1b in Western Europe is strongly associated with late Neolithic. So this is the earliest, not the youngest group. You see how big it is, how dominant it is in France. So this is a recent population influx. But you can also see J and E3b, the Mediterranean signals, right? These haplogroups suggest Mediterranean connectivity. How? Migration, Roman Empire, right? You get genetic drift, and this is how you get gene flow. But you can see relatively small. You have the I haplogroups. These are the pre-Neolithic early European layers. That's these blue groups right here, right? In the pre-agriculture population. So now you see a minor presence of R1. That's the yellow. That's a more common in Eastern Europe. So small presence in France suggests later continental mixing, migration, and gene flow across Europe over centuries. So when you look at the haplogroup dispersal in France, is that telling you France has a racial type? By looking at the haplogroups? Don't think so. France Y chromosome distribution reflect layered migration history, Paleolithic hunter-gatherers, Neolithic farmers, and from Anatolia, Bronze Age steppe expansion, Mediterranean interaction, ongoing European mixing. Can we say something about a French race? When all of these components are evident in the ancestry of what we see in France. It does not tell us that France is biologically homogeneous, that France people are a race, that paternal lineage equals total ancestry, that cultural identity equals genetic lineage. It reflects male lineage demographic events. Autosomal DNA would show a more blended, continuous pattern. See? So how does it all work? The collection of genetic data. Scientists examine many markers across genome, most commonly SNP, single nucleotide polymorphism. Single letter changes in the DNA sequence. We went over that, right? We understand that process now. So we are collecting all these genomes, we're swabbing all these peoples with deep ancestry, and we got all this genetic information. And we notice that there are single nucleotide polymorphism, SNP changes, single nucleotide changes in specific areas on these genomes. We can take thousands of them and analyze the data using different statistical models. So they measure a similarity, compare genetic markers between individuals, calculate how similar and different genomes are. Statistical calculations, computational, not biological in any sense. Statistical groupings, again, algorithm, structure, add mix NPCA group individuals into clusters based on genetic similarity. These clusters minimize differences within the group and maximize differences between the groups. For proper analysis, that is what you are going to do. To get proper analysis, you're going to measure the differences. You're going to look at the major differences in different populations, right? To make those distinctions, that is where you get that's where you get those initial k-mean, right? You get that global distribution as you see behind here now. You got k-mean distribution. So in interpretation, the output shows patterns of shared ancestry, historical migration, and gene flow. Clusters are probabilistic, not absolute. All right, so now we know what haplogroups mean. We're not doing that anymore. Haplogroups tells you nothing about race. Now let's look at heritability, the most misused statistic. And I stayed away from a particular paradigm for a specific reason because I want to address that topic on its own. Heritability measures the proportion of variation in a trait within population attributed to genetic differences. Is intellect a genetic difference? Anyway, but okay, I digress. It is population specific. It depends on environmental uniformity. Remember that. Environmental uniformity. It does not measure genetic causation between populations. Again, it does not measure genetic causation between populations. It does not mean immutability, right? So within groups, you can have different variations. These are not fixed things. We're going to look at the graph on the next slide. So height as heritability within population, but average height difference between populations can change dramatically with nutrition. Height heritability is not genetic destiny. This is where race-based determinations collapse statistically. So in the Netherlands, you have the tallest man, right? So he grew from 1914 to 2014. You can see a growth spurt. Why? Better nutrition, better diet, better social and economic, socioeconomic circumstances led to within 100 years, people growing over 10 centimeters taller. So the biggest gain in height for males was in Iran. That is also an indication of better diet, right? And better overall socioeconomic circumstances, right? Better health, better nutrition, etc. So you see again the bigger increase of almost 20 centimeters in growth in the population over 10 years, over 100 years, sorry. So now you go to South Korea, the tallest woman is still only 162, but you see they grew 20 centimeters in that same 100 years. Better nutrition, better diet. So you see, once you change the overall circumstances, that you get different outcome. Again, heritability is not a genetic destiny. And in Guatemala, you still have the smallest women. Although there's a 10 centimeter gain, they still remain the smallest women on the planet. So this is interesting. The average heights of male 19 years old, and you can look at per region where you see the tallest people. So you see in the Scandinavian countries, in Europe, especially in Northern Europe, you have the highest and the tallest people with an average of over 7 feet, almost 6 feet. They're 6 feet or more, right? Then you have the lighter regions, that's about 5'11" to 6 feet on average. And you can see the height dispersal over the world. Now, this is an interesting graph. Women, on average, they range between 140 centimeters to just about 180. So the least amount of women are 180. On average, women are about 150, 155 centimeters tall. Men, on average, are about 170, 170 centimeters tall, on average. The tallest men, smallest group of men, come into the 2-meter range. That's all the outliers. And you can see the shortest men are about they don't match up evenly, but here you can see there's a cutoff, there's the mean point at 170. Now look at NBA players. The average height is about 210. Compare that to the general population, they don't come nowhere in the equation. The smallest NBA player is about 170, and that is the average, that is a mean point between men and women. Men average about 170, and that is a low spectrum of NBA players. Again, how you measure data and how you look at statistics. The shortest people on the planet are still in Asia, unfortunately. Heritability, body mass index. Body mass index shows moderate to high heritability, often 40 to 70% within population. So there's a hereditary component to body mass index. However, obesity rates differ dramatically across countries. These differences correlate strongly with food availability, urban design, cultural diet, physical activity patterns. Heritability within population does not equal fixed genetic explanation between populations, right? Kuwait, fattest and fittest, adult obesity in high-income countries, most to least. So you have the highest, the fattest people are in Kuwait, the least fat people are in Japan. Utah, 44% of their population is overweight, whereas in Korea you have 7% of people are overweight. United States, you have 40% of the population are obese or overweight, whereas in France, 10% of the population is obese. So we can see, right, that would we look at these similarities between the United States and France? If we look at population, right, we can make a comparison there. What would be the big difference? Would that be food availability? I don't think so. Would that be urban design? To some degree. Would that be cultural diet? I think this plays the major role in the difference you see in obesity between France and the United States. Not a genetic link, more a cultural component, right? Skin pigmentation. Skin pigmentation is highly heritable within population, but global differences reflect historical UV radiation exposure, selection pressures over thousands of years. Important distinction. Heritable traits can differ between population due to selection, but that does not imply heresy, right? It does not imply hierarchy. It does not imply behavioral traits. It does not say anything about cognitive things or social categories. This is where overgeneralization often occurs. This becomes a problem, right? This goes back to these concepts of race, where one group is superior based on skin color and the other inferior based on skin color. This heritability is based on primarily historical exposure to the environment. When it became its heritable trait, but it is due to exposure in the environment which creates these diverse phenotypes. The closer you are to the equator, the more equatorial features you will develop independently across regions. As you can see, the phenotypes and the characteristics of skin color in Australia compared to that in Africa. Now we know that what you're looking at in Africa is a completely genetically different group of individuals that is in the Australia. We can track that, right? By means of these haplogroups, we can see where these genetic diversities emerge. Yet their skin color developed by means of convergent evolution, and that means it developed based on the environmental pressure. Says nothing about behavior traits, cognitive traits, none of that. Doesn't imply a hierarchy, none of it. All right. Medical race, where the confusion intensifies. Doctors sometimes use race as a proxy, right? Example, sickle cell trait frequencies in malaria region. People that look like us, we are more susceptible to sickle cell. Is that due to us being black? Or is that due to us coming from a particular region where this is a natural byproduct, an evolutionary byproduct of being in a particular region? So let's look at it. Sickle cell trait frequency, sickle cell trait frequency in malaria regions. These are the regions of the world where malaria is present. So now we are going to look at the sickle cell, and you're going to see an overlap, right? So ancestry-linked frequency, allele frequency changes, not race essence. Race is often a cruel proximity when finer tools aren't available. The problem is not acknowledging ancestry patterns. The problem is treating social race categories as biological types. So, what you're looking at here is the beta hemoglobin haplotype associated with sickle cell. You can see the Benin model. What that is telling you is that this is a place where this particular variant, right, this particular allele frequency change in the beta hemoglobin, that's what it's telling you, was first discovered there. That does not mean that this particular allele change, this particular mutation, did not occur in the other regions. It is not necessarily due to migration that you are finding the Benin variant in Arabia. It could have developed there independently, and most likely they developed there independently. You see some regions that you have all the variants present, and that is also could have developed independently or due to migration. It does not say one or the other. All these colors indicate is the region and the area where this particular mutation was first discovered. All right, so what you're looking at here is the areas where malaria is present. These are areas where a particular type of mosquito is present, and it overlaps neatly with the dispersal of sickle cell. Right? Yeah. This is the area where you get malaria, and look how the sickle cell variants match up to these places. Is this a migratory thing, or is it a evolutionary process? I think it's evolution, right? Convergent evolution. Continue. So what is a vector? The Anopheles. The Anopheles mosquitoes are found nearly worldwide, especially in tropical and subtropical regions, and have been introduced to temperate regions. They are uncommon in extremely cold regions and are not found in Antarctica. Malaria is responsible for more than 600,000 deaths every year. Control of the 30 or 40 Anopheles species, largely responsible for the disease transmission, is a major public health priority in many places around the world. That is the vector right there, the mosquito. That's the public health information. So again, race, not region. What we're looking at here, the distribution of sickle cell anemia haplotypes among nations with high prevalence of the disease. So you have 5 distinct beta hemoglobin haplotypes indicated by the colors. They are found in patients with sickle cell anemia. Each color represents a different haplotype named after the country in which it was first discovered, not necessarily its genetic origin. So you get a mutation in the beta haplogroup, you get the SNP change there, and now you have different variations of this particular mutation. So indeed, these haplotypes are not restricted to the eponymous nation, and they can be found broadly distributed. For example, the Benin haplotype in multiple nations, or multiple haplotypes within a single nation. So they can develop independently, not necessarily passed down via migration. Right? It is region dependent that you are going to find these particular traits.
What if your blood cells suddenly change shape and threaten your organs from within? For millions of people, that's not a what if. It's sickle cell disease. Sickle cell disease is an inherited blood disorder caused by mutation in the HBB gene, leading to abnormal hemoglobin S. Under low oxygen, hemoglobin S can form rigid chains, distorting red blood cells into a sickle shape. These cells also have a shortened lifespan, about 20 days instead of the usual 120, causing chronic hemolytic anemia. These sickled cells are prone to causing vaso-occlusive crises, leading to intense pain and potential organ damage. Major organs at risk include spleen, often becomes damaged or non-functional, raising infection risk. Kidneys, reduced blood flow can lead to chronic kidney disease. Lungs, acute chest syndrome can be life-threatening. Brain, strokes can occur at younger ages than in the general population. Thanks for watching. If this helped you better understand sickle cell disease, please hit like and subscribe for more essential medical insights.
You know what's interesting about sickle cell? Once you got the trait, it helps you to deal with malaria. Once you get the heterozygous of it, both from your mom and your dad, it can be life-threatening. Evolution doesn't have a direction. That's clear. You can see that there. So, typological thinking. What we think is on the left. What the reality is on the right. Gradients. Overlapping traits. What we believe, what we perceive is on the left. I'm going to say it again. And what the reality is on the right. Take your time. Look at the little map of the world distribution. Look at the flow of genetics. Can you relate the image on the left? Can you overlap that in any sense to the image on the right? No, you can't. So you understand the difficulty in having these racialized conversations. The reality is on the right. We over here, scientifically literate, are engaging with the information on the right as best we can to understand humanity, human evolution, human migration out of Africa, and just our place in this big thing we call a cosmos. Most of us are stuck with the image on the right. It makes these conversations impossible to have. That race idea is non sequitur. I don't care. It's irrelevant in this conversation. Do not take away my understanding of the history and the implication. Do not assume that there is no sensitivity there. But it is with scientific literacy and grounding in understanding reality is one of the biggest tools in helping combat that stupid, ridiculous notion of race. Did my little rant, sorry. So race thinking historically assumes fixed biological types, the picture on the right. Clear boundaries, essential traits, immutable categories. Thick lips, nappy hair, and a broad nose. Chinese can't have that. The Olmecs must be African. Look at the nose and the lips. That's not a normal tropical feature developed over time, selected for by nature. No, he needs to be the dude on the lower right. Don't know what type of Asian that particularly is. I can't tell if it's Chinese, Japanese, Korean. But y'all get the picture now. What reality is on the right, and it is what it is because it's impossible to categorize that. It's impossible to put phenotypes to that. Very limited. But it all flows in and out of each other. Again, go back to my initial, the overlapping graph. Whatever trait you want to put on whatever group is going to come back in the other. Modern evolutionary biology rejects typology. It operates on variation, overlaps, gradients, probabilities, and gene flow. Clustering becomes racial typing only when statistical patterns are re-edified into fixed categories. That moves the whole discussion of haplogroups from probability to essence. And that was never the objective. So what we're dealing with is a social construct layer. Race are social constructs, meaning categories were historically defined, and we go over and over when that came about. We understand cuando los africanos se pusieron negros. Los africanos de África Central Oeste. No, that's East. Central West Africans. The Portuguese said, ellos son negros. They're black. There was nothing other than look at you, phenotype. There was skin color. Non-haplogroup, no study, no interest in understanding the population. Just the objective to enslave those things that we can call black. See, it look black, Grab it. That's the root of these arguments we're having. Boundaries shift over time. Today, anybody can be my nigga. We use black in my Caribbean context completely different. We align black to your cultural expression, how you talk. Yeah, you don't talk like you black. You don't sound like you white. So even a white boy could be black because he don't talk like he white. You understand? These are over time boundaries shift. One drop rule. Everybody on this picture, by means of the one drop rule, can be black. Let's face it, right? Everybody on this picture, by means of the one drop rule, can be black. Right? Definitions vary per country. Political and legal systems codify them. Biology did not create those boxes. Society did. Genetic variation exists. The box interpretation is imposed. Population genetics reveal ancestry patterns and geographic structures. Race reinterprets those patterns as fixed biological types. The science describes gradients. Social construct draws lines. So in my closing statement, genetic reveals patterns of variation. It measures ancestry, allele frequencies, and population structure. It does not produce biological races. Clustering is statistical. Haplogroups trace single lineages. Heritability describes variation within populations, not destiny between them. The attempt to revive race science today does not use 19th century language. It uses genomic terminology. But the move is the exact same. Turning gradients into boundaries, right? So what we see is gradients, you have fixed categorical boundaries. What is probabilistic into essence. This is what it is. No, this is how we determine or choose to map the data. The data that is provided is based on the categories that we determine. There's no essence there. Turning population patterns into fixed human types does not exist. Any particular trait that you want to attribute to one particular group is going to overlap significantly and to some degree with the other population group. It always does. Oops, sorry. The science does not require that conclusion. Fixed population groups. It doesn't need that. Don't care. Human variation is real. Biological race as a discrete natural category is not. Again, biological race is not real. So when we slow the claim down, the distinctions become clear. This has been said, Doc. Thank you very much for listening to me. I hope this clears up the conversation and we can have these conversation about migration, human genetics, haplogroup variations, and the like, without all the heavy baggage. And if I made any mistakes, I am open to all correction. And if you want to make it into race, I'm here to beat you up.
True indeed, man. Good shit, man. Hey, if anybody want to hit the link, man, you know what I'm saying, y'all can come on in and jump on. If you got any questions or disagreements or whatever. I see some more people that came in the building, man. I see Akeem 4700, JG11, U3X, Pan African James, what's happening? Audio Hawaii, what up, dog? Who else we got in here, man? King.
So when I say L0 and gave rise to L3 and L3 gave rise to M and N, you pretty much know what we're talking about right now.
Mm-hmm.
Yeah, that's a mitochondria, haplogroups, The L is the earliest lineages in Africa, and the reason it's classified that way is just based on the fact that they started the study in the United States with the native population, which made sense, right? Because that's a fixed population group that you can really go back into the ancestry. So that is what establishes the way that the data was interpreted. The data provided the hierarchical structure just based on what the data itself produced. So L is an African haplogroup, yet you can't use haplogroups to define race. Wow. Is African a race? Which African is a race?
Mm.
So if Africa has L0, L1, L2, up and including L6 as mitochondrial lineages, which race are we talking about? You see, like, he just doesn't get it. He refuses to get it.
Yeah.
So the J marker is a dominant haplogroup in the Levant region and in Egypt. Let's say Egypt, especially Upper Egypt. Does that mean that the Egyptians were not indigenous? No. It says based on the way haplogroups are measured, right, that this particular lineage over time spread. Like if a father has 5 sons, his sons have 3 boys each. Those 3 boys have 2 boys each. One brother dies. That is still going to be a dominant haplogroup in a community, because once you measure the haplogroups, the lineage of the father of the female that you reproduce with falls off. It doesn't tell you that there are not the other haplogroups in that society, right? It just tells you that it's not going to be dominant. It doesn't tell you that there weren't other male lineages in that society. It's just not going to be dominant, right? And again, when you look at very small population groups, 100 here, 50 here, 40 there, this group breaks off. Early human, we are looking at 55,000 years ago. The earliest data that we use in haplogroups is 25 to 30,000 years ago, folks. Come on. Deep ancestry.
Life in Life 24 says human population structure is biologically real. Race is socially enforced taxonomy built around that structure. Calling race socially constructed does not mean it lacks biological correlates. Does not mean it lacks biological correlates.
No, it doesn't, but it means that race isn't biological, that there's no thing as biological race.
All right, let me see what
You get it? You get it? They can use biology to create race, right? By lookership. But if you say, based on these parameters, 1, 2, and 3, this is black race. You're going to look at parameters 1, 2, and 3. 1 and 2 is going to correlate with what you call the European race. So if 1, 2, and 3 makes me a black race, how does 1 and 2 not? What does 1 and 2 make the European? Because the European has the same 1 and 2. Mm-hmm. And with the Malaysian group, 2 and 3 correlate with my 2 and 3, and with 2 from the European. So which one is which race then? Because these races all overlap. The whole idea of race falls apart when you put it to scientific scrutiny, simply using biology, right? Because you are going to see gradients, you're going to see overlap, you're going to see there are no clear definitions. Anything, if you say nose, I am going to use nose to determine a race. So, okay, in Africa, you're going to have 17 different races, right? Because you're going to have that variation per population. And then once you have those 17 races, you're going to see, wait, but you belong to this race based on the nose, but based on eye color, you will not be in this race. Or, but it's not 100% like this race. So it's long, but it's still broad. It doesn't fit in none of the categories. So the whole idea of race falls apart. That's why that graph, that last picture with the 5 so-called races versus that whole breakdown creates a confusion in your optics. One represents the reality, that multitude and that flow, and the other represents a concept created out of full ignorance. Which one are you going to continue to use and engage with? Which one becomes paramount in your engagement with the world? We are the pseudo killers. We say scientific literacy gives you the tools that equip you to make everyday decisions that is best for you, your family, and the general community around you.
Mm-hmm. Life and what's up, Sabio? We got Sabio in the building.
What it do, Sabio?
What up,
Life
Nick? What up, Dad?
ain't too much, man. Let me read the question real quick. He said, gender is a social construct that is built around biological elements. Does this mean gender is purely social construct with no biological correlation? Framing is key
Is
here.
biological correlation to every social construct, but doesn't make it fixed. That's the whole idea. If you take gender by our classical definitions, and let's look at what is considered woman and man role, not from a biological standpoint, just from a social standpoint. This is how I ended that argument with my dad real easy. Who's supposed to do the cooking? Oh, the woman is supposed to be doing the cooking in the house, right? She's supposed to do the cooking. I said, okay, good. So when you go to a restaurant, what do you expect the chef to be? So why, when you go out, you expect the dude to cook, but home it is a woman? Does that make sense?
Mhm.
So these are these social constructs that fall apart or that continue to change based on social changes and adaptation. But the biology is what it is. I am never going to give birth. I'm never going to reproduce because I have XY chromosome. But
I think
if you tell me that I'm less of a man because I like to cook, that's that gender thingy that makes no sense, and that is fluid based on your society and
yeah.
based on your social norms.
Mhm.
I think the question was misframed. I think he meant to say was sex social, because gender roles are socially assigned, but sex isn't. Sex isn't social. But the gender
Mhm.
roles are socially assigned. Like you just said, that's a great example.
Yeah,
Why would you?
I try to use those simple examples to make it as easy to follow. But uh,
Hey, James, hit the panel, man. You getting all this stuff in the chat, man. Hit the panel
so
so we can.
now paleontologists, paleogeneticists identify Africans in they identify non-Africans based on the mutations that happen outside of the continent, right? So if you look at there's variations within the continent itself, right? Let me see. We can go back to that slide. Now, give me a second. Share my screen. Type screen. Share my screen for a second again.
All right.
So this slide right here, is showing you the variety of haplogroups within Africa, a variety of sub-haplogroups. So you have the major haplogroups E, And these are all the sub-haplogroups in Africa. There's genetic variety within Africa. But these mutations did not happen outside of the continent. And because of the laws, the amount of people that remained on the continent, you have far less of these subgroups like you see outside of the continent. These clear, distinct markers, they occur because of bottlenecking. When the population shrinks, the mutations become more prevalent. They are selected for easier. But on the continent, you have the variety, the genetic variety that you see in front of you. So let's count them. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 sub haplogroups and branches. Right here, you can see that variety on the continent. But these are all these are African mutations. So don't think that there are no mutations on the continent. Non-Africans are simply those within the conversation of out of Africa migration based on haplogroups and the study, we can determine these mutations happen outside of the continent. That's it. That's what makes them non-Africans. The fact that there is 2% admixture with Denisovan or with Homo sapiens with Homo neanderthalis is simply over time those were selected for, right? Whatever those components attributed to the overall autosomal genome, autosomal now, and only 2%. And in the autosomal region, we're not looking at any Neanderthal admixture whatsoever when we're talking about haplogroups. So the interjection of Neanderthal in the conversation is like why? It is only outside of we are looking at the migration patterns of early humans. Again, the data we are looking at with regard to haplogroups goes back to at least 30,000 years ago. It's not nothing new of today that we're looking at. We're looking at deep ancestry within your genetics. You can be black, come from West Central Africa, and you can have autosomal material from Asia, right? Or etc. It's different layers. So when we're looking at haplogroups, you're looking at old ancestry based on the fact that it's passed down from father to son. You're misusing the information again, Neanderthal James.
Mm-hmm. Yeah, so it look like ain't nobody trying to hit that link, man. I'm pretty sure people gonna be watching watching it back tomorrow too.
Yeah, leave your comments, questions in the chat. I check them all. I reply where necessary. It helps the channel grow because it shows interaction. But when we put the set talks down like this, there is little room for your interpretation.
Oh yeah.
Hey,
Go ahead,
what,
Sabio, what you about to say?
what you just was talking about. I don't know if you heard me presenting that Naomi Zach paper on racism and race the other day, yesterday. But
No, man, you got to come and put your work down right here on the Pseudo Killers platform, so it's archived, man.
Oh yeah.
It's about time. It's about time we have that conversation that the Jew been having for a long time. I think we're here now. It is just like the primate conversation and monophylology. I think the community is mature now and grown enough to now engage with these questions. So when the question is that do you come from monkey? Well, technically, see, the word monkey is being used in a colloquial sense, and it creates some confusion, right? old world monkeys. We all come from old world monkeys, including monkeys you see today. But that doesn't mean we evolved from the monkeys we see today, because those monkeys have their own evolutionary track as well, right? So that's why slowing down the conversation is necessary. And it's part of scientific literacy, it's part of scientific discourse. We are always using these haplogroups in conversations, and you can see now how incorrect someone like James has been using this data for years, just misappropriating the data, misinterpreting what it means, because he is not grounded in what is being said. Statistical computation is not going to give you no information about your race. When we're looking at the DNA, how we match it up is where the data was collected, correlates with certain mutations that we find in these SNPs. That's it. Doesn't tell you anything else. If you understood what I broke down, an individual could be autosomally European, Chinese, and be mitochondrial wise African, and be Y chromosome wise have a J marker, right? Autosomal is what you're looking at when you're looking at what we are today. When you're looking at deep ancestry, and that deep ancestry that we look at serves one purpose. It is understanding the out of Africa migration model. That's it. It wasn't meant to tell you your race, your creed, none of that. It is supporting and giving genetic evidence to support the out of Africa migration. That's it.
Yeah, man. So we're gonna go ahead and man, thank everybody for coming through. You know what I mean? It's been a good one, man. Shoot, man. Ace, we're gonna be back at you. What we're gonna do Wednesday again next week? I know we didn't do it yesterday.
Of course, next week Wednesday we'll be back. We'll be back with my next topic. I'm observing what is going on in the community. There are certain directions I'm thinking about going, but of course, I'm going to do my research and put another awesome show together. So I'm gonna see you guys next week, Wednesday, 9:30 for another Set Talks. Stay tuned to find out what. Thank you for being here.
Yes, sir. Yes, indeed, man. Appreciate everybody coming through, man. Y'all make sure y'all hit that like button on your way out. You know what I'm saying? And leave a comment in the comment section after the video is over, man. Peace.
Gon' die, they saw a pseudo-killer. I'm a pseudo-killer, intellectual sunslinger. I'm a pseudo-killer, intellectual sunslinger. I'm a pseudo-killer, intellectual sunslinger. Pseudo gon' die, they saw a pseudo-killer. I'm a pseudo-killer, intellectual sunslinger. I'm a pseudo-killer, intellectual sunslinger. I'm a pseudo-killer, intellectual sunslinger. Who do you believe in? People bringing misinformation when that information ain't disinformation. That's disinformation. Gotta know the difference in information. Get information with the pseudo-killer army hunting pseudo. Cause you gotta train your mind to fight against them pseudo-judo. People with the scholarship salute, we give them kudos. But the people with that look of shit, we look and see straight through those like telescope. If you ain't speaking fast, we gotta tell them folks and let them know the truth. You bringing malinformation to blast, then you the Ku Klux. Like say, don't talk me to death, bro, what the proof of? Good juju chillin', why you wanna go way bad juju up? Shalom boy got the tank in the cut. I'm in Sosa world plotting on the kick though with Kent. Commit Tiffany gave me the pseudo names on the list and said went and got the low. Anthony got him in the scope, Gullah and Gozy make sure DNA ain't a problem for them folks. Cause a pseudo gon' die, they saw a pseudo-killer. I'm a pseudo-killer, intellectual sunslinger. I'm a pseudo-killer,